Have you ever looked up at the night sky and wondered about the light from those distant stars? How long has it traveled to reach your eyes? Light is more than just what lets us see. It's a time machine, a messenger from the past, and the fundamental energy that powers our universe. Today, we're re-embarking on an incredible journey to discover Lumen, the very essence of light, and travel through time and space to understand its profound secrets. From the first spark of the Big Bang to the fiber optics that connect our modern world, we're going to explore how light has shaped everything we know. So, get ready to see the world in a whole new light. Let's start at the very beginning. Nearly 13.8 billion years ago, in the moments after the Big Bang, the universe was an incredibly hot, dense soup of particles. It was so dense that light, or photons, couldn't travel freely. They were constantly being scattered by charged electrons and protons. Trapped in a cosmic fog, for about 380,000 years, the universe was completely opaque. Then, something amazing happened. The universe expanded and cooled enough for protons and electrons to combine and form neutral hydrogen atoms. Suddenly, the fog cleared, photons were set free, and for the first time ever, light could travel across the cosmos. This first light is what we now detect as the cosmic microwave background radiation. It's the oldest light in the universe, an afterglow from its birth, and it carries the secrets of our cosmic origins. From this grand cosmic scale, let's zoom into our own little corner of the universe, our solar system. The star of our show is, of course, the Sun. The light from the Sun takes about 8 minutes and 20 seconds to travel the 93 million miles to Earth. This means that when you look at the Sun, please don't always use proper protection. You're seeing it as it was over 8 minutes ago. If the Sun were to suddenly disappear, we wouldn't know about it for 8 minutes and 20 seconds. This time delay effect is a fundamental concept in physics. It's not just the Sun. The light from Proxima Centauri, our nearest stellar neighbor, takes over 4 years to reach us. When we look at the Andromeda Galaxy, the nearest major galaxy to our own, we're seeing it as it was 2.5 million years ago. We are literally looking into the past. Astronomy is a form of time travel, and our telescope is the time machine. But how did we even figure this out? The story of our understanding of light is a fascinating journey in itself, filled with brilliant minds and revolutionary ideas. For centuries, people debated the nature of light. Was it a wave or a particle? The great Isaac Newton, in the 17th century, championed the idea that light was made of tiny particles, which he called corp. This explained why light traveled in straight lines and cast sharp shadows. Around the same time, a Dutch scientist named Christian Huygens proposed that light was a wave. His theory beautifully explained phenomena like diffraction, where light bends around obstacles. This debate raged for over a century. Then, in the early 19th century, Thomas Young's famous double-slit experiment seemed to settle it. He showed that when a beam of light passes through two tiny slits, it creates an interference pattern on a screen behind VMA pattern of bright and dark bands. This is classic wave behavior, like ripples in a pond. For a while, the wave theory reigned supreme. James Clerk, Maxwell then unified electricity, magnetism, and light into a single theory of electromagnetism, showing that light is an electromagnetic wave. It was a monumental achievement. The case seemed closed. But science is never that simple. At the turn of the 20th century, a new puzzle emerged. The photoelectric effect. This is the phenomenon where light hitting a metal surface can knock electrons loose. The wave theory couldn't explain why only light of a certain frequency could do this. Enter Albert Einstein. In 1905, his miracle year, Einstein proposed a revolutionary idea. He suggested that light isn't just a continuous wave, but is also quantized into discrete packets of energy, what we now call photons. This revived Newton's particle idea in a new, more sophisticated form. So, which is it? Wave or particle? The bizarre and wonderful answer from quantum mechanics is that light is both. It exhibits properties of both waves and particles, depending on how you observe it. This concept, known as wave-particle duality, is a cornerstone of modern physics and highlights the wonderfully strange nature of our reality. This dual nature of light is not just a weird theoretical concept. It's the foundation for technologies that have completely reshaped our world. Let's talk about lasers. The word laser is an acronym for light amplification by stimulated emission of radiation. At its core, a laser works by exciting atoms to a higher energy state and then stimulating them to release photons that are all perfectly in sync. They have the same frequency, phase, and direction. This coherent light is incredibly powerful and focused. Lasers are everywhere. In barcode scanners at the grocery store, in Blu-ray players, in delicate eye surgery, and in industrial cutting tools that can slice through steel. And what about the device you're watching this on right now? Your screen, whether it's an LCD, old, or something else, is a masterpiece of light manipulation. Each tiny pixel is a source of red, green, and blue light that can be precisely controlled to create millions of different colors. It's a tiny, intricate light show happening thousands of times a second to bring this video to you. But perhaps the most transformative application of light in the modern era is fiber optics. Imagine sending information not as electrical signals through copper wires, but as pulses of light through tiny strands of ultra-pure glass. This is the magic of fiber optics. A light signal, typically from a laser, is beamed into one end of a glass fiber. As it travels, it bounces off the inner walls of the fiber in a process called total internal reflection, losing very little energy along the way. This allows data to travel at nearly the speed of light over vast distances. The internet, global telecommunications, high-definition television, none of it would be possible at the scale and speed we enjoy today without fiber optics. These invisible rivers of light connect continents and carry the collective knowledge of humanity. Light has also revolutionized medicine. Beyond laser surgery, we have technologies like which are a high-energy form of light, allowing us to see inside the human body without making a single incision. Scans use magnetic fields and radio waves, another form of light, to create detailed images of our organs and tissue. Endoscopy uses fiber optics to guide a tiny camera inside the body, enabling doctors to diagnose and treat conditions with minimal invasion. Light isn't just helping us understand the universe, it's helping us understand and heal ourselves, and the journey isn't over. Scientists are constantly pushing the boundaries of what we can do with light. We're developing new types of solar cells that can more efficiently convert sunlight into electricity, promising a cleaner energy future. Researchers are exploring quantum computing, where photons could be used as qubits, the fundamental units of quantum information, potentially leading to computers millions, half-times, more powerful than today's supercomputers. We're even using optical tweezers, highly focused laser beams to grab and manipulate individual cells, viruses, and even DNA molecules. The future, it seems, will be lit in ways we can barely imagine. So, from the first light of creation to the digital glow on your screen, Lumen light is the thread that connects everything. It's a particle and a wave. It's energy and information. It's a tool and a work of art. It's a window into the past and a beacon guiding us toward the future. The next time you flick on a light switch, or gaze at the stars, or see a rainbow after a storm, take a moment to appreciate the incredible journey of light. It has traveled across billions of years and unimaginable distances to make our existence possible and to fill our world with wonder and color. It's the silent, brilliant storyteller of the universe. Thank you so much for joining me on this journey through time and light. I hope it's given you a new appreciation for the incredible phenomenon that illuminates our world. If you enjoyed this exploration, please hit that like button and consider subscribing for more deep dives into the wonders of science. Let me know in the comments what aspect of light fascinates you the most. Until next time, stay curious.